we're going to work on understanding the standard normal distribution. So standard normal distribution, aka the bell curve. So the bell curve has a shape that's almost like this, and as nearly perfect as this is, I understand it's not quite perfect. So if you follow the link that's on D2L, you can get to a better rendering of this. Let me take a quick look at that. So right here is a better, just slightly better bell curve. And what we're going to do is work on trying to understand some of its properties and find the areas underneath this bell curve, because this is going to be useful throughout the rest of the course. So let me give you a few properties about the bell curve, and then we'll get down to business and playing with some things. So the top 4 facts about the normal curve. I should say the standard normal curve. So the first thing is that it's symmetric, my drawing notwithstanding. So it's symmetric. The total area underneath this curve is 1. So total area under the curve equals 1. Just like when we were working with probability density or probability distributions, all the probabilities had to sum up to 1. Now that we're working with a continuous distribution, the total area underneath that curve is 1. What do I mean by this next one? Mu equals 0, sigma equals 1. What's mu? The mean. So the mean is 0. The standard deviation is 1. That's unique to the standard normal curve. You can have other normal curves with different means and different standard deviations, but the standard normal curve has a mean of 0 and a standard deviation of 1. Most of the area underneath this curve is going to be between -2 and 2. Most of the area under the curve is between -2 and 2. And almost all of it is between -3 and 3. Almost all of it is between -3 and 3. And finally, we'll see this later, but we'll give you the Google Sheets command for it right here. So Google Sheets. The Google Sheets command to help find some of these areas would be norm dist of x, which is going to be your value. And then you type in the mean, standard deviation, and then just trust me on this last one, true. That's going to give you something called the cumulative distribution. But let's play around with this a little bit and start understanding some things at a basic level. So I'm going to go over to my little curve on Desmos and start showing you some things. So if the total area underneath this curve is 1, then how much of the area is to the right of 0? So 0 to infinity. How much is in this shaded region if the total area is 1? Half. So 0.5 is in either side of the mean, or 0 in this case. Now to find these areas in particular, we're going to use a z-table. So let's take a look at this table A2. You can look in the back of your book and understand how this is going to work. Now some of you might have a little card, and that's great. A little fold-out card that's part of many of your books. So it would look like this and have z-scores on it. If you don't have that card, it's been torn out and lost or whatever, then you should be able to find this as table A2 in the back of your book. Now the variable that we use to discuss the standard normal curve is a z variable. And what this table is going to give you is the area underneath the curve to the left of a particular value of z. Let's start with, let's see, which one do I want? Problem number 10. Area to the left of negative 1.04. So let me see if I can't graph that for us, just so we can kind of get a little handle on what that's going to look like. So let's see. So negative 1.04. And I want the area to the left of that. So it's nice to be able to draw these things. And in fact, I've got some graph paper that I can pass around here for you, so you can try and draw some of these things. I actually got 2 sets of graph paper, one for you to use now, one for you to use later, so don't feel about using it up. But one thing first, in looking at this, is this area going to be less than 1/2 or greater than 1/2? Less than 1/2. All right, it has to be, because it's to the left of 0. So if I want to find the probability, or the area underneath this curve to the left of negative 1.04, then I'm going to go to the table. So let's take a look at table A2. And this is problem number 10. Actually, you know what? We're going to do 2 things. Probability that z is less than negative 1.04. That's going to be the area to the left of this point. Now you're going to see 2 digits right here. The first one to the left of the decimal and the first one to the right of the decimal. That's going to comprise your columns here. So you want to go down till you find that first part, 1.0. So that's going down. You pick up that next digit by going across. So negative 1.0 is all the way down here. They're going to go to the right until you get to 0.1492. And that's going to be the area underneath the standard normal curve to the left of negative 1.04. So let me draw that. Yeah, 0.1492. So negative 1.04. Not much area there. Just under 15% of the area is to the left. But what if I wanted to figure out how much area was to the right? If I wanted this area in blue. Yeah. This area right here is going to be 1 minus the 0.1492, so 0.8508. And you could write that as probability that this random variable, say z, is greater than negative 1.04, which is 0.8508. 508. So again, to use this table, the first two digits comprise your row. This last digit comprises your column. So putting those two together, you should be able to find the area out of these numbers. We're going to practice a lot of these. Let's try another one, problem number 18, unless somebody has some comments or thoughts on number 10 here. Okay, so let's try problem number 18 then. This time I want the area to the left of negative 0.19. So in the center of my distribution is 0. Negative 0.19 is a little bit to the left of that. Does this probability have to be less than 0.5 or greater than 0.5? Less than, because I want this area to the left. So less than that. Again, your first two digits tell you what row you're dealing with, and the third digit tells you what column you're dealing with. So go down until you find negative 0.1, all the way down, almost all the way down to the very last row, second to last row, and then all the way across. What area are you getting for this? What are you seeing off your table? Good. So all the way down over here should be 0.4247. By contrast, if I wanted z to be greater than negative 0.19, what would I do to find that area? Yeah, 1 minus this. So it'd be 1 minus 0.4247, so 0.5753 would be this unshaded area. Actually, let's just shade that green. So that'd be that area. Let's move over to the right side of 0 with the next one, problem number 20. And you're going to get really familiar with this next value. This time I want z is less than 1.96. So the area underneath the curve to the left of 1.96. So 1.96 is going to be out here in the tail. And as before, I want to find that area. So probably a couple ways you could do this. This time you're going to be looking up something from the positive z distribution, or positive z values. So flip over to the next page. Positive z-scores. 1.9 is a little bit below midway down, and then over to 6. You should get a fairly round number. What number are you getting for 1.96? 0.9750. Good. So that means 97.5% of the area is to the left. That leaves a simple 0.025, or 2.5% of the area is out in the right tail. Let's start looking at problems where we've got two z values to contend with. In problem 26, I want to find the area underneath the standard normal curve that's between 1.23 and 2.37. So say here and here. Now I'm just guessing these things. The only thing that's really important is that I draw them on the correct side of 0 together. In this case to the right. I want to find the area between these. But that's not exactly how my table works. My area doesn't give me the table between things, it gives me the area to the left of things. So how am I going to find just that little piece? Yes. So what we'll do is we'll first find the area to the left of 2.37, and then we'll subtract off this piece, the area to the left of 1.23. So you're going to have to look up two things, write them down, and then subtract them. So 2.37, start out with the 2.3. 2.3 takes you down to this level, and then across to the point that you're underneath the 0.07. So the 0.07 should be on top of this column. So I'm getting 0.9911. Is that what you guys are getting? All right, so 0.9911. That's the area to the left of 2.37. Now the area to the left of 1.23, a little bit easier, 0.8907. So 0.1004. Double check me on that. Math was never my strong suit. All right, good. Thank you. A couple people caught that. Thanks for being awake. All right, problem number 28. This time I want you to try this one, and I'll kind of walk around and help out a little bit. If you're having trouble finding these values, please let me know. You're going to have to go back to the z distribution, the negative z distribution for this one. So negative 1.93 is less than z is less than negative 0.45. So try and find this area between those two. If you get that one, you can try our next one, problem number 30. Negative 3.90 less than z less than 2.00. Okay, so again, you got to look through your tables. I'll start by looking up 0.045. So negative 0.045, negative 0.045, get 0.3264. So down to negative 0.4, then underneath the 0.05, 0.3264. Minus the area to the left of negative 1.93, so negative 1.9, that's down here, and then across to the right until you're underneath the 0.03, so 0.0268. We subtract, it's 0.2996. How many people got that first one right? Good deal, good deal. Okay, let's keep going then. Problem number 30. Area to the left of 2, 0.9772. Sorry, I've got that one memorized. It's just in my sleep. I know that one. You'll know some of these things too if you've done it a while. Negative 0.390 is a little bit interesting because your z table only goes to about negative 3.5. And then after that, they just kind of wave their hands and say, okay, anything lower than negative 3.5, just use that area, 0.0001. So the area to the left of 2 is 0.9772. The area to the left of this, we're going to round it up, in this case probably generously, to 0.001, giving us a difference of 0.9771. So, cool. So some z values. How are we looking on these? Probably want us to do some more practice on them as well. But, you know what? Maybe we should, well, yes. We'll do some more practice in a little bit. But for now, I want to switch things up a little bit. We're going to start looking for the z value that corresponds to a particular area. So this is going to mean using the table in reverse. I'm going to give you the area that we're going to work with, and then we're going to try and find the corresponding z value. So let me give you some notation first. This is notation that we're going to use throughout the rest of the book. So more Greek letters for you. That's the Greek letter alpha, or at least my rendering of it. If you want to see a better rendering of it, you might want to look in the book. But z sub alpha is going to be the point on the normal curve with alpha percent of the area in the right tail. So z sub alpha is going to put alpha percent of the area in the right tail. So it's percentiles, just like we dealt with in the last test. And problem 42 asks you for z sub 0.01. And we're going to have to think about this a little bit in relation to what we're asked for and how the tables work. Z sub 0.01 is the point on the standard normal curve with 1% of the area in the right tail. So that number is 0.01. But when you look at your charts for the standard normal curve, that's not how they work, is it? The standard normal curve tells you the area to the left of something. So that's why we're going to have to understand and look things up, is the area to the left. Now, if there's 1% of the areas in the right tail, how much does that leave in the left tail? So how much is in this green region? 99. So 99%, or 0.99. And then, because this is a nice even number, I'll round it out to 4 digits by putting in the 0.990. So that's the area that we're trying to find in the left tail. So let's take out our tables. Now, is this point going to be to the right of 0 or to the left of 0? Should I be using the positive z table or the negative z table? Positive, yeah. This definitely, 99%, that definitely has to be in the right tail, because 50% would take us to 0. So look in your table, and you want to find an area as close to 0.99 as possible. It would help if I had the positive z table. There we go. Now, I'm not going to ask you to interpolate. There's plenty of programs that can do that for us. But just find whatever's closest. 0.9900. Yeah. So, yeah, 233. So it's between these two, but you're closer to 0.9900 here than you are here. Here you're off by 2 10,000ths. Here you're off only by 1 10,000. So 2.3 is the first 2 digits, and then you go to the top of the column, and you'll see the next digit, which is a 0.03. So put them together. 2.3 plus 0.03 gives you 2.33. Is effectively in the 99th percentile, separating the bottom 99% from the upper 1%. So z sub 0.01 is 2.33. Before we do this with problem number 44, is there anything about problem 42 that you'd like a little more help with? Going backwards and forwards in this table is going to become a big part of this course, so let's practice this some more with problem number 44. That's a good one. Yeah, like that one. So this time, problem number 44, they want z sub 0.03. So that means that 3% of the area is going to be in the right tail, 0.03, or 3%. But if I want to find this value, what am I going to have to look up in the z table? What number should I look up there? Yeah, I'm going to need to look up the 0.9700. So I want to find the area, or the z value that corresponds to having 97% of the area in the left tail. Effectively, this is the 97th percentile. So 0.9700. So again, go back to the z table. Look around and try and find something as close as possible to 0.9700. Now, chances are it's going to fall between a couple values, so just pick whatever is closest. Amira, what'd you get? Okay, some help? Yeah, 1.88. So looking down, it's 0.9700 falls between these two, but it's closer to this one. So this is at the row for 1.8, and you look up the top of the column, you get the other 0.8, so that's 1.88 for the z value. 1.88 for the z value. Let's try two more, and these next two kind of go together. So they're my own examples, they're not examples in the book. Z sub 0.09, and then Z sub 0.91. I'll give you a hint. If you do the first part, you get the second part pretty much for free. Okay, so if 9% of the area is here in the right tail, then the area in the left tail is going to be what? Yeah, 91%. So 0.91. We'll throw in a couple gratuitous zeros just to make it easier to compare things. And if you're looking for something close to 0.9100, then you get pretty close with 1.34. So you're down here. The closest thing you can find in the table is 0.9099, and that corresponds to 1.34. So 1.34 is your z-value here. Now the second one, it helps to really think about what this represents. Z sub 0.91. Well, that z sub whatever is the area in which tail? The right or the left? It's always the area in the right tail. Always. So the area in the right tail has to be 91%. So that's this area over here is 91%, or 0.9100. What's that leave for the left tail then? If this is 91%, then this is 9%, 0.0900, 9%. Now, the result shouldn't surprise us, but we'll follow through with this anyways. If you're looking up the point on the curve with the area of 0.9 or of 9% in the area in the left tail, well, it certainly can't be a positive number because we're to the left of 0, so it has to be a negative. So we'll look up in the negative z table of 0.09. So we'll look around 0.09. So right down here, and it's negative 1.34. Not really a surprise if you think about it. Z sub 0.91 equals negative 1.34. This is symmetric. The standard normal curve is symmetric, so the point with 9% in the area in the right tail is going to be the opposite of the point with 9% of the area in the left tail. They are completely symmetric. So if you had one, then you could get the other one. In fact, it used to be that books would only publish like the positive z-score, because you can get everything by symmetry. But they found it was easier for students to have both of them, so now you get both of them. Let's do one more like this. A question? Yes? You don't want to memorize this? Yeah. No, the z-score sheet will definitely be memorized. Not memorized. Yeah, will definitely be provided to you. Now, my big quandary is like, well, what do I do about Google Sheets? Because Google Sheets can do this as well. So I have to work on that. But I would count on knowing how to use the sheets. Okay, because sometimes they're going to give you slightly different answers. Google Sheets probably doesn't round their answer as much as what's going to be done in the book, and that'll affect things a little bit. So, but let's do one last one like that one, and it'd be Z78. So find Z sub 0.78 and Z sub 0.22. Now, if you're smart, you're only going to do half the work that you did maybe with the last one. Okay, so if you're asked to draw these things, well, I'm not really going to ask you to draw these things from scratch. I'll give you most of it. But z sub 0.22, is that going to be this one here or this one here? The one on the left or the one on the right? The one on the right, because it's going to put 22% of the area in the right tail. That means 0.7800 is to the left of this point. And that's where you can begin looking for things, is try and find out, well, what point has about 78% of the area in the left tail. Now again, your tables show you what they're giving you. This is the area to the left of this z value. So that area has to be about 0.788. So in looking at your table, it's somewhere between these two values. And if you think carefully about it, 0.780 is closer to 0.7794 than it is here. If you really wanted to force the issue, if you're like, oh, I just don't know, here's what you could do. You could take this first value, 0.7823, and subtract off 0.7700. And let's compare that to the distance the other way. 0.77 minus where was the other one? 7794. You know what? I should have been subtracting 0.78, right? Yeah, let me go back here and redo this one. So up here. So subtract off 0.78. See how close we are that way. And then 0.78 minus the other one, 0.7794. So if you really wanted to figure it out, then you could. This one is a lot closer. That's 3 zeros and then a 6. In any case, 0.77 is this value here. Equals 0.77. Now, if 0.77 puts 22% of the area in the right tail, what z value is going to put 22% of the area in the left tail? We got the first one. Yeah, it's just going to be on the other side of 0, right? Remember, these curves are symmetric. So to the left of this was going to be the point negative 0.77, which puts 22% of the area in the left tail, and then 78% of the area in the right tail, which is exactly what this is, z sub 0.78. So what I want to do is I want to give you some homework here. For homework, try problems 9 through 39. This is section 6.2. 6.2, 9 through 39, and then 40, 41, 42, 43, and 44. So usually I assign just the odd problems. And it's just the odd problems there. But in this case, I'm assigning a few even problems. Now the good news is that we've already done a couple of these in class. I'm encouraging you to practice them a little bit. Make sure that you're comfortable with this, because, like I said, this is going to come back at you again and again throughout the rest of the semester. So I really want to make sure that you got it down now. Okay, good luck with that.